Friction is a force that works in opposition to the motion of an object, meaning it slows down the motion of the object. It occurs between two solid bodies that are in contact with one another. Imperfections at the interface between the object and the surface bump into and rub against each other. This is what causes friction. Static friction occurs when a body is stationary and on a surface. It can be expressed by F is greater or equal to the coefficient of static friction times the normal force. The coefficient of static friction is a number between 0 and 1, but does not include those numbers. It is a ratio of the force of static friction and the normal force. The larger the coefficient, the harder it is to move those two objects past one another. Static friction increases in magnitude until movement begins. Let's look at this example to better understand static friction. A 10 kilogram box is placed on a horizontal surface. The coefficient of static friction between the box and the surface is 0.4. What force is required to initiate motion if the box is initially at rest, already moving with a constant velocity, and moving with an acceleration of 2 meters per second? Now, to solve A, the force required to initiate motion is given by the maximum static frictional force, so we can use its formula. Now here, Fn is mg, so we can rewrite the equation, and we can plug all the values in, which would be 39.2 newtons. So the force required to initiate motion is 39.2 newtons. Now for B, if the box is already moving with a constant velocity, it means that the applied force is equal to the frictional force. Since the box is moving at a constant velocity, the net force is 0. Therefore, the force required in this case is 0. For part C, the box is not just moving at a constant velocity, it is accelerating. So to find the force required to maintain this acceleration, we need to consider the overall force acting on the box. Now, Newton's second law states that the net force is equal to mass times acceleration. In the case of the box moving with an acceleration of 2 meters per second squared, we need to consider the force of static friction and the applied force. Now, this would give us the equation F net is equal to F applied minus FF, the force of friction. Now, we can substitute all the values in, which would give us MA is equal to F applied, which we are solving for, minus the coefficient of static friction times mg. Now we can plug all the values in. So this would give us, for the applied force, 59.2 newtons. Dynamic friction occurs when a body is in motion on a surface. Now it can be expressed as Ff is equal to the coefficient of dynamic friction times the normal force. The coefficient of dynamic friction has similar properties to that of static friction, yet dynamic friction has a definite force value for a given situation, whereas the force of static friction has an increasing force value. Let's look at this example to get a better understanding of dynamic friction. A 1,200 kilogram car is moving on an inclined plane with an angle of 15 degrees to the horizontal. The coefficient of dynamic friction between the tires and the road is 0.2. The car is moving with a constant speed of 25 meters per second up the incline. Determine the force of dynamic friction acting on the car. First, let's visualize this scenario. Now that we have a visual representation of the scenario, we can easily solve A. We know that the formula for dynamic friction is FF is equal to the coefficient times the normal force. Now here, we realize that the normal force is in fact the weight times cos 15. Now we get cos 15 because cos is the adjacent side and the hypotenuse. In this case, it would be this is the adjacent side and that's the hypotenuse, meaning that Fn, we can rewrite the equation to FF is equal to coefficient of static friction of dynamic friction times mg cos 15. And now we can simply plug all our values in, which will give us a frictional force of 2,274.18 newtons. Now, part B, if the driver applies brakes, causing the car to decelerate at a rate of 2 meters per second squared, calculate the net force acting on the car. Now, we know that the net force is F is equal to ma, and it gives us the value of the acceleration, which is negative since it's decelerating, so the net force would be equal to 1,200 times -2. And now we must add the force of dynamic friction, which acts in the opposite direction, minus 2,274.18 would give us a force of F is equal to negative 4,674.18 newtons.